Hello students, a very good morning to all of you. This is Dinesh Mayobani in the video lecture series of numerical methods in chemical engineering. In the last lecture we have studied about exact numbers, approximate numbers and significant digits. We have studied the three definitions. We have also studied the important topic like accuracy and precision. What is the difference between accuracy and precision? We have studied that with the help of one example. In accuracy, we have to compare two values, true value and the approximate value, while in precision, we are comparing the individual measured values. Right, so this was about the accuracy and precision that we have studied in the last lecture. In this lecture, we are going to take some numericals of rounding off, and after that, we are going to study about the types of errors. How many types of errors are there? What are errors? What is the importance of the errors, right? So let's start. Okay, see, in the last lecture we have studied what is the meaning of rounding off. Okay, rounding off can be done by two ways, rounding up and rounding down. What is the meaning of rounding down? How we are rounding down? Rounding down is used when the n plus 1th digit is less than 5, and rounding up is used when the n plus 1th digit is greater than 5. And if the n plus 1th digit is exactly equal to 5, then we have to replace the nth digit by the nearest even decimal number. Right? So on the basis of that, we are going to study one numerical. So let us solve this numerical. What is given? Round off 2.2535 to 3, 2 and 1 decimal places. Okay, now what is the meaning of decimal places? These are the decimal places. After decimal point, these are known as the decimal places. So we have to round off this number to 3, 2 and 1 decimal places. Okay, so let's start. See, this is our given number 2.2535. We have to round off this number up to 3 decimal places. So we have to round off up to 3 decimal places. These are the 3 decimal places. So to round off, first of all, we have to consider two numbers. One is nth digit and another one is n plus 1th digit. So here, as we have to round off up to 3 decimal places, see, this is our nth digit, this one is our n plus 1th digit. Here we can say n plus 1th digit is exactly equal to 5. So what we have to do? We have to write the nearest even decimal that should be larger than this. So up to 3 decimal places, I can write this number as 2.254. Up to 3 decimal places. Okay. Similarly, I have to round off this number to 2 decimal places. How I can do that? Okay. I am writing the number again, 2.2535. 2 decimal places means we have to write up to 2 decimal places after the decimal point. So this is our nth digit and this is our n plus 1th digit. So we have to check n plus 1th digit. N plus 1th digit is less than 5. So we have to neglect these two numbers and we have to write only 2.25. So our answer up to 2 decimal places will be 2.25. Okay, is it clear? Now let us represent this number up to 1 decimal places. Only 1 decimal place we have to take. Let me write the number again. 2.2535 is my number. Up to 1 decimal place means I have to write only up to this. Again I have to check this. Okay, this is my n plus 1th digit. This is my nth digit. Here we have to check n plus 1th digit. On the basis of the n plus 1th digit, we can round up or round down. Fine. So this is again exactly equal to 5. So we have to write the nearest even number. So 2 is the nearest even number. So my answer will be 2.2 up to 1 decimal places. Fine. I hope it is clear to everyone. So in this way we can represent the number up to 3, 2 and 1 significant digits based on the n plus 1th digit. Fine. Clear? Next example, you have to round off the number 37.3248 to 3, 2 and 1 decimal places. So we will solve it very quickly. First of all, I am writing the number here, 37.3248 up to 3 decimal places. So we have to consider up to this. This is our n plus 1th digit. This one is our nth digit. Here we can see n plus 1th digit is greater than 5. So we have to add 1 in this. So my answer will be 37.325. Okay, if I want to write this number up to 2 decimal places, so these are the 2 decimal places. Here the n plus 1th digit will be 4. 4 is again less than 5, so we have to neglect these 2. So my answer up to 2 decimal places will be 37.32. Okay, and again if I want to write the number up to 1 decimal place, then I have to only consider this 3 because 2 is less than 5, so all these 3 digits will be neglected and my answer will be 37.3. So in this way we can round off the numbers, okay, by using that rounding off concept. Okay. Okay, let's move on to the next important topic, that is errors and types of errors. First of all, we will define what is the meaning of error and types of error. This theory is very much important for the GTU exam point of view. So first of all, let us study what is error. So what do you think? What is an error? Error means if there is any mistake, that is known as error, right? In general term, we term it as mistake. But in mathematical terms, what is the meaning of error? See, if I am having one value, okay, if I am doing any experiment, I know that this should be the answer. I am having one reference value. We will consider that reference value to be the true value, and after measuring, we are finding an value. We are finding a value, okay, that is a measured value. There is some difference between that two values, and that difference is known as error. The actual value is known as the true value, means we are expecting our answer to be the true value, but after measuring it is not exactly same as the true value, but there is some difference, and that is known as error, right? So if we want to define error, error is defined as the difference between the true value and the approximate value. Fine, so this is about error. Let us study the different types of errors one by one. There are basically 5 types of errors. The first one is absolute error, and it is denoted by EA. Okay, what is absolute error? Absolute error is a numerical difference between the true value of a quantity and its approximate value. Let us consider the true value as xt and the approximate value as xa. So EA can be given as xt minus xa. We have to take the magnitude of this because we want absolute value, right? So EA is equal to xt minus xa. This is known as absolute error. Fine. Now next type of error is relative error. Now what is the meaning of relative? We are relating the absolute value with some value, and which is that value? So we are relating the absolute error with the true value. So if I want to define ER, that is relative error, it can be given as absolute error divided by true value. Okay, what is our true value? True value is xt. So if I want to write it numerically or mathematically, it can be written as EA upon xt. But what is EA? So EA is the absolute error, and it can be given as xt minus xa whole divided by xt. So this is about relative error. Now percentage relative error, third type of error is percentage relative error. if I will multiply the relative error by 100 and I am finding the error in percentage, that is known as percentage relative error, and it is denoted by EPR. Okay. So this is the expression for EPR. EPR is equal to xt minus xa upon xt multiplied by 100. These are the three errors. These are the three types of errors. Now next errors are inherent error and truncation error. Let us study one by one what is the meaning of inherent error. Okay, inherent error. Now as the name suggests, inherent means what? Inherent means it is related with heredity, means it is already present. So if we want to define the inherent error can be defined as the error that is already present in the statement before its solution is known as the inherent error. It's already present. You are not doing any type of error in measuring, right? But the error is already present in the instrument. So error that is carry forwarding from one level to another level, that is known as inherent error. Okay, and these types of error can be reduced by taking high precision data. If we take the data with high precision, then we can minimize this error, and we can also say this type of error depends upon the limitation of the instrument. Okay, and we are taking approximate data. This is also one of the reasons that this type of error occurs. And the last one is truncation error. What is the meaning of truncation error? See, I will show you with help of example. Take one example, sin x. Sin x is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial, and so on up to infinity. This is the general formula for sin x in terms of expansion. See, while doing calculation, we are considering only first few terms. We are neglecting the remaining terms. So there might be some error while calculating the final answer. So that type of error is known as truncation error, because we are not considering the full series. We are considering only first few terms. For example, my first answer of sin x is capital X, and if I am neglecting some terms and I am considering only few terms, then my answer will be x dash. So there is a difference between x and x dash, and that difference is known as what? Truncation error. So we select only few terms and we neglect the remaining terms in a series. Fine. So this was about the types of errors. This is most important topic as per the exam point of view. So I hope it is clear to everyone. Okay students, let us study some numericals based on the errors. These are asked in GTO exams. Okay, what is the given statement? You can see, if 0.333 is the approximate value of 1 by 3, find absolute, relative and percentage errors. We are already having the formulas to find absolute error, relative error and the percentage error. So let's start. See here, let the true value be xt is equal to 1 by 3 and the approximate value that is given, that is 0.333. Now in the case of true value, which value we have to consider? Okay, we are considering here 0.333333. So after 0.6 decimal places are there, we are considering it as a true value. We can also consider after point we can take 7 values, we can take 8 values, we can take 9 values. It depends on you. Okay, so we are considering here the value of 1 by 3 after 6 decimal places to be true value. So to find the absolute error, we have to simply subtract xa from xt. So we have to subtract 0.333 from 0.333333. My answer will be 0.000333. Okay, this is my absolute error. Then I have to find relative error. To find relative error, the formula is EA upon XT. So my answer will be 0.000999. We have to just divide that value. Okay. Then we have to multiply it by 100. Then we will get the relative percentage error, that is EPR. Simply we have to find the values of this error by placing these values in the calci. You can easily find these values, right? Okay, next numerical. This is again asked in GTU. Round off the number 865250 and 37.46235 to 4 significant figures and compute EA, ER and EPR. We have to again calculate all these three errors. But first of all, we have to round off this number. So it is a combination of two things. We have to round off and then we have to find the errors. Okay. Let us consider case number 1 in which we have to round off the given number up to 4 significant digits. How we can round off with the help of that formula? How we can round off to 4 significant digits? See, as we know that after decimal point the trailing zeros are significant, but here we have to consider only first 4 significant digits. So first 4 significant digits are 8652 and the remaining 2 will be zeros. Okay, up to 4 significant digits means what? 8652 are the significant and remaining 2 we have to round off. So again the remaining 2 will be zeros. So this is the given number. We will consider the given number as a true value and the approximate value will be 865200. We have to place all these values in the formula. We have to place all these values in the formula. You will get the answer. Okay. Again, ER you have to calculate. You have to divide EA by XT. You will get the answer. Okay. Then multiply that answer by 100. You will get the relative percentage error. I am not going in detail because you can easily solve this. The main thing is just how to do round off. Okay. Again, 4 significant digits means we have to consider only first 4 digits. So my approximate value will be 37.46 and the true value will be 37.46235. Okay. So XT and XA both are available. With the help of these two values you can easily find absolute error, relative error and relative percentage error. Okay. So this was about the numericals. You can solve these numericals by yourself. Okay. This was about unit number 1, approximation and errors. In the next lecture we are going to start unit number 2. Okay, that is solution of algebraic and transcendental equations. Till then, have a good day. Bye bye.